seen the video lectures and slides of week 7?
Yes, ma'am, I have seen 4 lectures out of 5.
Okay. What about others?
Yes, ma'am, me too.
So, I have already seen the slides and lecture uh, for week 7. So, you know the topic where functions of one variable. Here you have learned about linear function, quadratic, in general polynomial function, and trigonometric function. Exponential function, logarithmic function, right? You
Yes,
are
ma'am.
already aware of all those functions, right?
Ma'am, your voice is dropping again and again.
Okay. Now it's clear?
Yes, ma'am.
Yes, ma'am, fine.
So, function, so let me first write down the topic which already covered in week 7 that we will do into this session. So it was a function of one variable. Then you learn what is the sequence, limit of a sequence, limit of function, and continuity of a function, right?
Yeah.
Ma'am, are we going to have some questions or not?
Yeah, we will solve some example question. Parallelly, we will first define this, all the definitions and all the concept. Then we will solve some question example based on this. Okay.
Okay, ma'am.
So,
Ma'am,
yes.
yeah, ma'am. I have a doubt in trigonometric function that discussed in lecture 2.
Okay, I will cover this trigonometric function also. When
And also,
at
ma'am,
that time you
ma'am,
can have your doubt.
yeah.
Okay.
Oh. And ma'am, can I talk in Hindi when because I am not good at English, so that
No matters
when I ask,
actually.
okay. When I
No
ask my
matter.
doubt, when
You
I ask
can
my
talk
doubt in
in
Hindi.
English. No. Yeah, you can ask, but better if you want to learn English, you can talk to English. Okay.
Yeah, ma'am. Yeah, I'm trying.
Yeah. Try to, otherwise it's fine.
Yeah.
So, I think during our week 5, we already covered what do you mean by a function, right? Function is basically
Yes, ma'am.
the relation from A to B such that every element of A maps to a unique element of B, right? Right?
Yes, ma'am.
That
Yes,
we
ma'am.
know, that we already know. And this was the domain, and this was the codomain for our function f, right?
Yes, ma'am.
Then
लेकिन मैम
we
ये
know.
या मैम कैन आई आस्क
Sure.
ये मैम जब हमने रिलेशन ऑफ फंक्शन जब हमने पढ़ा था तो वहाँ पे वन फंक्शन के लिए ऐसा बोला गया था कि वन इनपुट वन आउटपुट, लेकिन यहाँ तो फंक्शन को ही डिफाइन करने के लिए वन इनपुट वन आउटपुट बोल दिया गया.
Uh, No, it's not one input, one output.
Means unique
So,
input, unique output, ma'am.
the image is unique. Like one input, one output is fine, but there may be another points which are going to this same image. Okay,
Yeah.
this is correct for a function, but this is not correct. One element is, if it is going to two different elements for a relation, then this is not a
Not
function.
a function.
Okay,
Yes, ma'am.
this is a function. This is not a function. So that these things you already know, right?
Yes, ma'am.
And then you know what is a polynomial, right? And also we learned how to draw graph for polynomials, how to like see how, the end behavior and all. We already covered it, right? So polynomial is also a function, okay,
Yes.
from R to R. This is also function from the set of real number to the set of real number. Now you all know a polynomial can be written as the form, right? Where
Yes, ma'am.
this n equals to 1, 0, 1, 2, dot, 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 n. This belongs to the integers, positive integers, right?
Yes, ma'am. Means natural number.
So we can expand this as px equals to a naught plus a1x plus a2x squared plus dot 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 an xn, right? Then
Yes.
what then we say that this is a polynomial of degree n, right?
Yes.
It's a polynomial of degree n. Now, if our n equals to 1, that means the maximum degree is 1. Then px equals to a naught plus a1x, right? When the maximum degree is 1, then we have this polynomial, and this polynomial is said to be a linear function. Okay?
Linear function.
Yeah.
Yes.
If the maximum degree is 2, then what do we say? This polynomial is?
Quadratic
Yes.
function.
Then this is a quadratic function. So,
Ma'am, it should be a2x square, right?
Yes,
yeah,
ma'am.
yes, yes. Thank you. So, now you know what is the linear function, what is a general polynomial of degree n, and what is a quadratic function, right?
Yes.
Also, you are about this type of function. This type of function are called exponential function, right?
Hmm.
And when a equals to e, we know this is a natural exponential function, right?
Yes.
Also, and week 6, we covered what is logarithmic function, right?
Hmm. Hmm.
This is from 0 infinity to r. Now, we added one new kind of function which is trigonometric. So there are 6 functions which are specifically the trigonometric function is sine function, cos, tan, cot,
Cot, sec, cosec.
right? So basically, these are the 6 trigonometric functions. And you already know the chart, right? Sine of like from theta equals to 0 to pi by 2, right?
Yes, ma'am.
Yeah. In our
मैम
first
व्हाट डू यू
quadrant,
मीन बाय मैम मुझे यहीं पे
yes,
दिक्कत हो रही है कि इसका मतलब क्या होता है
किसका मतलब?
मैम 0 to π/2 मैम बहुत जो क्वेश्चन में आता है
Okay,
कि
okay,
π/2
okay.
या इसके बीच बीच में है
Huh. So
तो
pi by 2 is a real number actually. Pi is approximately 3.14 something,
3.14
right? Huh.
यस
So actually this pi is one irrational number, okay? And if we are saying some theta equals to pi by 2, that means this right angle, okay? This angle is pi by 2, okay?
मैम राइट एंगल मींस 90 डिग्री
Yes, 90 degree.
π/2 मींस
Pi
90 डिग्री
means pi means 180 degree,
ओके
right?
ओके ओके या
So
या
pi by 2 is actually 90
90
degree.
डिग्री
Pi by 4 means 45 degree.
45 डिग्री
Yeah. Pi by 3 means
30 आई थिंक 60
and
या
pi
60
by
degree.
6 means 30 degree.
30 degree.
30 डिग्री
Yeah. So you know this is 45 degree, this is 90
यस
degree, and you can measure 30 degree, 60 degree and all up to 180 degree, right? This is a
यस
180 degree. So this is basically the slope. Like if we have a function like this, if suppose I want to check what is the slope at this point, then it will be this line, right? And the angle is basically theta. This angle is slope of the curve, okay?
मैम कर्व और टेंजेंट दोनों
Slope
का
and tangent both are same.
या
Ma'am,
Slope and tangent both are same actually. Yes.
can I ask a question, ma'am?
Mm-hmm.
Actually, when you said theta is equal to 0 से pi by 2, right?
Yes.
So you just restricted its domain. You defined a theta is equal to 0 to pi by 2.
Yes.
Why?
I restricted the domain to this. But these functions are also defined in this domain also.
Okay.
You can extend this, no problem. N pi by 2 up to n pi by 2. No problem. N is any real number, n is any integer. Okay.
Okay.
Even you can take some negative point. For this, the rotation will be in this side. Okay. And if we are taking something positive, then the rotation will be anti-clockwise. Okay.
anti-clockwise yeah
So no matter what is it, it can move. It is n pi by 2 actually. So you know the value of the functions in this points when theta equals to some n pi by 2, right?
yes
Yeah. So what was your doubt regarding the trigonometric functions?
मैम इसका फंडामेंटल क्या है मतलब कि मैं जिसको समझ लूँ तो मतलब पूरा कॉन्सेप्ट का अंडरस्टैंडिंग हो जाए मतलब बेसिकली वहाँ पे ये मतलब पढ़ाया क्यों जा रहा है हमको ये समझ में आ रहा है कि साइन का मतलब ये है कॉस का मतलब ये है इतना डिग्री बनाता है
Okay, these are
साइन मतलब वाई एक्सिस
basically some. Okay. So these are basically some some special function, and using this type of thing, there are so many applications in various fields like physics and all. Okay. Some like if we want to provide wave equation for some, then light equation. Okay. So for this type of thing, we use this trigonometric functions.
और मैम
And
मुझे
in
थोड़ा
mathematics,
ग्राफ में भी परेशानी हो रही थी कि वहाँ पे मतलब वो
acha,
जो सर्कुलर
okay.
सर्कुलर जैसा
We
था
will
मैम
cover the graph. So if we pick specifically the sine function, sine theta, so you know that when theta equals to 0, sine theta is 0, right?
यस
When
मैम
theta equals to pi by 2, then sine theta is 1, right?
मैम 90 डिग्री होता है ना, क्योंकि वाई एक्सिस होता है साइन थीटा और कॉस थीटा एक्स एक्सिस।
Yes.
मैम सर्कल में,
Okay.
जो
Okay.
सर्कल मैम जो कॉन्सेप्ट होता है।
Circle is basically the equation of a circle is sine square theta plus cos square theta, right? This is equals to 1. We know, right? This is equation of circle.
यस
Specifically, if you see the graph of a sine function, then it will be like this, right?
यस मैम सर्कुलर
Yeah. This is our positive 1. This is our negative 1.
1
And
minus 1।
when x equals to 0, the functional value is 0. That means the function passes to the origin, right?
यस
So if we this is a function, right? We can define it as f of theta. And how do we plot the graph? The graph will be just the
मैम थीटा का वैल्यू जो प्रोवाइड करेंगे
movement
उसी के
of
हिसाब से
this
साइन
point.
फंक्शन होगा।
Yes. Mhm.
मैम इसका एक सर्कुलर होता है 0 से 2 पाई।
Yes.
मैम
This
इसका
is
मतलब क्या
pi
होता है 0 से 2 पाई मींस?
and this is pi. So you can see if from 0 it is
यस
here in the origin, then when it is pi by 2 it reaches to the point 1, right? Then
यस
again when it is pi it's 0. And similar for
माइनस पाई बाई
this,
2
yeah,
माइनस
this
पाई
is
बाई 2
minus
माइनस 1।
pi by 2, yeah, minus 1. And here again it's 0, right?
यस यस
So if we can, like, you can consider it, right? This is similar to a upper half of the circle, and this is similar to a lower half of the circle. If we just cut the function from here, just consider from here to here. Okay. Then
यस
everywhere the functions are similar, periodic, right?
यस मैम
If we just flip the function with respect to this line over here, okay, then it will be similar, like, right?
यस मैम
You just
Yes.
flip this function, then it will be similar. Like just rotate it and flip. Okay. So this is
Yes, ma'am.
basically a periodic function. And this is the period 0 to 2 pi.
2 पाई इसका एक एक पूरा जो एक बार एक 0 से 2 पाई तक होता है इसका।
Yes, this is a period. Because see,
इसमें एक पीरियड होता है। यस
this is the turn in the positive side and this is in the negative side. This and this we cannot say it's same. But if we say the whole wave, including the positive and negative both the side, then it's again same, right? Again positive, again negative and same. Right?
और मैम एक्टिविटी क्वेश्चन बहुत सारे ऐसे क्वेश्चन हैं जिसके बारे में लेक्चर में पढ़ा ही नहीं गया, मतलब लेक्चर में बहुत लिमिटेड ही
Okay,
पढ़ाया
so
गया, लेकिन वहाँ पे
we will cover all the activities question and all. So first it's important to learn the concept, okay? First to try to
base
learn
of
the concept, then we will again cover all the activity question and practice question, okay?
Can I ask one single question, ma'am? Ma'am, how to approach math, ma'am? How to approach math?
How to approach
Because,
math?
yes, ma'am. Because I have put it much more time, but very difficulties.
You have to
Ma'am,
check the points. If you have some function, then the graph of this function is basically movement of this point, right? Which is the x coordinate and this is the y coordinate, right?
Y coordinate. Yes.
Yeah. So basically you have to check, you have to plot the movement of this point. If now what you can do, you can just see some points here. Like when you are putting theta equals to 0, the outcome is sine theta equals to 0. That means the function, the graph include this point 0, 0, right? Similarly, this point pi by 2 comma 1. So this point is basically our pi by 2 comma 1. This point is pi comma 0,
0.
pi comma 0.
Yes.
So we are saying that similarly you can check this point, okay? When you will put some pi by 3, then we will again get f of pi by 3, right?
Yes, ma'am.
It is some approximate value, okay? So according to that, you can see what is the location for this function. You
Yes.
have the x coordinate, you have the y coordinate, and then you have to plot the movement of this point. Okay,
Yes.
this is the proper method to draw a function. And now for a periodic function, you can see if you draw this. Let me use some another color. If you just draw this wave, and you can easily see that the function is a periodic function of period 0 to 2 pi, right? Then
Yes.
you have to just follow the same. You have to follow the same. Just copy the same thing, and it will be your whole function. Okay.
Yes.
And if we take the cos function, yeah. So the graph of a cos function, at the point,
Pi by 2, I think. See,
yes,
pi to 0,
at
pi by 2.
0, cos 0 is 1, right?
Yes, ma'am.
That
Cos
means
0 is 1.
this is one point. At pi by 2, cos is 0, right?
0.
Minus pi by 2, cos is
Yes.
0.
0.
This is our one. This can be something like that, right?
Yes.
Yes, ma'am.
So this is our 0, 1. This is our pi by 2, comma 0. Sorry, minus. This is
Minus
our
pi by 2.
pi by 2,
Pi by
comma
2, 0.
and all. The cosine function is also one
Periodic
periodic function,
function.
right?
Yes,
Of
ma'am.
Yes, ma'am.
same period, this to this. And again, in the similar manner, you can draw the graph for 10x. This is also a periodic function, and this is something like that. You can
Ma'am,
say,
what is the crux of the graph?
yes.
Ma'am, what is the summary of the crux of the graph? What is convey? What is the meaning?
This
Tan
is the
theta
meaning.
graph.
Basically, this tan theta is again a periodic function, and you can see this will repeat from minus pi by 2 to pi by 2.
Pi by 2.
Yes.
What is periodic
Uh,
function?
mhm.
What is periodic
Ma'am,
function?
ma'am, so that is bounded function.
Okay, you don't know what is periodic function, right?
Ma'am,
Yes.
just repeat sometime.
Basically, if you have the broader domain, and if
Cyclic
a
function.
function it will repeat the same value or same type of structure after some value, then it will be a
Okay.
periodic function. See, we have tan theta as our function here, right? And domain R, we are taking the whole real line. But you can see if from minus pi by 2 to the pi by 2, in this region, the function is like that. And again, from pi by 2 to pi, the function will be similar, right?
Okay.
So in this
just like
period,
minus
minus
1,
pi
1,
to
minus
pi,
1, 1
again,
as
you can take a difference of pi. So period pi basically, okay? It will
Okay.
be similar kind of function.
It's a function actually that repeats its value at a regular interval.
Yes. Actually,
Yes.
after after some interval, it will repeat the same structure.
Yes. Thank you.
Basically, the periodic function. So these are tan function, okay? And you can
Ma'am,
see,
this is a bounded function.
no,
Ma'am, this is
not
bounded or unbounded?
no, this is unbounded because it's a asymptote for our function.
Yeah,
This will
yeah.
tend
Don't.
to infinity. This will tends to
Yeah.
infinity. What we know,
Okay.
then when at theta equals to pi by 2, tan theta is infinity, right?
Yes.
Ma'am,
Yes.
what is the meaning of asymptote?
Okay.
Asymptote.
So asymptote, I think you should know what is asymptote because we have covered problem including asymptote already. So it's basically nothing but if we have some function like that,
Asymptote
then
is a Well, actually, asymptote is it's a straight line that constantly actually
Yes.
approaches a given curve, but
Yes.
does not meet at any infinite distance.
Yes. Yes.
वो सिर्फ देखने में लगता है कि टच हो रहा है लेकिन होता नहीं है
हाँ,
बेसिकली.
Yes.
right.
When the n variable is something tending to infinity, then you can plot the limit, and you
Basically, we can say that asymptote is a line that curves approaches as it moves towards infinity. Actually,
yes,
x
yes.
बराबर 0 पे x बराबर
हाँ.
0.
When not x tends to 0, for this case, you can
Yes, for
see
this
that
case,
when
yes,
x
for
tends
this
to
case.
pi by 2, this f of x tends to infinity, right?
Yes, ma'am.
So in this case,
Yes, ma'am.
this x equals to pi by 2 line is asymptote for this curve, okay? Again, this point is asymptote, this line is asymptote, okay? So the tan function is one of the example which have infinitely many asymptotes, okay?
Oh, new crux. Okay, ma'am.
All the lines are asymptotes here, okay?
Yes,
Yes.
ma'am. And all the lines which are at the multiples of pi by 2.
Yes. This is one asymptote, this is one asymptote, okay?
Yes, ma'am.
So yeah, that is all about trigonometric function. Actually, what you know that tan theta equals to sine theta by
On cos theta.
cos theta, right? So when we know at x theta equals to pi by 2, cos theta is 0, right?
Yeah.
That means we
0
have
point some.
something, yes. That means we have something like 1 over 0, right? So this term is not defined, but we can
Undefined.
say this is actually tends to infinity, right?
Yes.
So these are the basic concept about your trigonometric functions. So any further doubt with the concept of trigonometric function? You
No,
have
ma'am.
some application in physics and other field. For now, our concern is to learn the theoretical portion, okay? So I
मैम बस
think
वही है कि
trigonometry,
वहाँ पे कुछ फॉर्मूला दिए हुए हैं जो नहीं लेक्चर में दिया गया उनको बस पढ़ना पड़ेगा.
yes, yes. Kuch, so the formula you have to like check and just try to mind it, okay? So now we can discuss about sequence. So it's again a function, a particular type of function. So basically, if I have a function from the set of natural number to the set of real number, this is a sequence, okay? The sequence is basically a function from the set of natural number to the set of real number. This is a real sequence, okay? And generally, we
इसका मतलब क्या होता है?
this is a sequence. Like for every natural number, 1, 2, 3, and all, you will get some F1, F2. Okay.
Yes, ma'am.
Ma'am,
And
F1, F2, and F3 are belongs to real numbers.
yes, F1, F2, F3, they belongs to real number, and 1, 2, 3 we're taking for natural numbers. So this F, the function we can denote is as Fn. So naturally Fn or An. In this way, you can denote a sequence. Or sometimes we can use this notation also, but maximum time we will use this notation. Okay.
Yes.
There are so many notations for the sequence. We will use this notation. So
हम जो यहाँ पे n है वो डोमेन को दर्शाता है.
Domain is natural number, yeah. And the codomain is real number.
Real number.
So a sequence, yes.
Yeah, madam. So that means the domain should always be the natural numbers starting from 0.
Yes.
Can't have any negative numbers.
Yes. Yeah. If we're talking about a sequence, then it's basically a function for which natural number is the domain. Okay.
Okay.
Hello, ma'am.
Yes.
जीरो इंक्लूडेड है इसमें?
That is
I think no.
actually dependent on you. If you take this set, this includes 0, which is basically set of whole numbers. But here, according to the Python system, we are assuming this as a natural number system because this is basically similar to the natural number. Okay. So sometime you may see some question that they will include A0, A1 and all. This is also a sequence, no problem. But normally it will start from A1, okay? Basically, if you now you are aware about the concept of bijective functions, right? So if
Yes.
we have some set A and B, and if we have a bijective function from A to B, then we say that A and B, the set are similar, okay? Then if we have two similar sets, then instead of working with the one set, we can also work with the another set, okay? If we have, suppose, if we draw a function from n to n0, such that n goes to n minus 1, okay? Then what do you have? 1 goes to 0, 2 goes to 1 and all, right? This is the
Yes.
function. So this function is 1, 1 and on 2, right?
Yes, ma'am.
Yes, ma'am.
It's bijective.
That means it is a bijection. So basically, from the set of natural number to the set of whole number, we have a bijection, right?
Can you repeat that again, like the part,
Yes.
the bijection
Okay.
part?
So this is a simple concept. If we have some two sets, A and B, and if we have a function from A to B, which is bijective, then we will say that the sets A and B are similar, okay? And this is a notation to be similar. Okay, this is a notation. That means the set A and B are similar. Now, if we have two similar sets, then working with A or working with B, it's basically same. Instead of A, you can consider the set B. Again, instead of B, you can consider the set A for some problem. Okay. So if we define some function f from the set of natural number to n0, that n goes to n minus 1, or we can also define a function from n0 to n such that n goes to n plus 1. So both the function are bijective, right?
Okay. Yes, ma'am.
Yeah, both the function are bijective. So basically the n
One single question,
and
ma'am, please.
yes,
Every bijective function is a similar.
bijective function is not similar.
Not similar. Sets are similar.
We
Sets
have
are
some,
similar.
yes. If between two set, if we have some bijective function, then we can say that those two sets are similar, okay?
Okay.
So from natural number to n naught to the set of whole number, we have a bijective function. And again, from the set of whole number to the set of natural number, we have one bijective function, these two, right? So we can say that n and n naught are similar. So if we define the sequence from the set of natural number, then also we can define the sequence from the set of whole number, okay? This is basically the same thing.
Yes, ma'am.
Ma'am, the letter F is the inverse of the formal F.
Yes, actually. Huh. So this is basically F inverse. So I think now it's clear for you. For a sequence, for now, I will use the notation for natural number because it's more convenient for me. But you can also take the whole number here. Okay. Those two sets are similar, so no problem with any one of them. So for now, I will proceed with the set of natural number. Okay.
Yes, ma'am.
So basically, this is a concept for a sequence. So any doubt regarding concept of sequence? What a sequence is? Any doubt?
No.
No, ma'am.
Ma'am, define in one line.
Sequence is basically a function from natural number to real number.
Okay.
This is the definition you can use. Function from n to r.
R.
Okay.
Ma'am, it can be any function, right?
Yes, it can be any function.
Hmm.
Suppose we have 1, 2, 3, 4, and all. This is a sequence. Suppose we have 1/2, 1/4, 1/8, and this is another sequence. So you can see this is a function f of n equals to n, right? This is a function, right?
Yes.
So you can click this. It's 1 function. It should be 1. Okay? Injective function. So
Oh,
here
yes, ma'am.
again you can say it's 1 by f of n
2n.
equals to 1/2n. No, not 2n. It's
Oh,
2
no,
power
yes.
n.
Yes, ma'am.
Okay, it's 2 power n. So this is the function and this is the sequence relative to the function. Clear? These are some example for a sequence. So any further doubt with the concept of a sequence?
No, ma'am.
Okay. So now we can move to the limit of a sequence. So we have one convergent sequence
And divergent sequence.
and divergent sequence. This is the short form for sequence seq to the power n. I will use this CONT and DIVT for the convergent and divergent sequence. Okay.
Yes, ma'am.
Okay, ma'am.
So basically, if we have the sequence tends to some number which is belongs to real number as n is tends to infinity, then we will say that sequence is convergent, right? Right?
Ma'am, what
Ma'am,
is meaning?
repeat it, ma'am,
Basically,
please.
Ma'am,
yeah.
simplify, ma'am. Simplify.
Yes. It's basically, suppose we have 1, 2, 3, 4, and all. This is our natural number set. This is our 1, 2, 3, 4. So when our n is tends to infinity, that means when we are going this way, suppose the functional value is coming to some point, some 0. Suppose some 0. Okay. It's if you plot the graph using this function, it is something tending to 0, right?
Yes, ma'am.
This is something tending to 0. So in this case, we will say when n tends to infinity, our f of n tends to 0, right?
0.
Yes, ma'am.
Yes, ma'am.
You
0
can
positive.
consider, yes, you can consider this example, right? In this example, when n will tends to infinity,
And it
2
will be
power
0.
n
Yes,
will be
ma'am.
again tends to infinity, right? So 1/2
Yes,
power
ma'am.
n will be tends to 0.
0.
So this is an example for a convergent sequence. And you can see here, and divergent sequence means basically which is not convergent. That means if n is tends to infinity, there is no real number such that n is tends to that number. Okay. In that case, we will say the sequence is divergent. Okay.
Is that like asymptotes, no?
Not, yeah, you can say it, but in that case, it's like asymptote, but not in general. It can be a function, something like that.
मैम एक से एक के बटे में जो भी रहता है जितना बड़ा
limit,
नंबर से हम उसको
okay.
भाग देंगे उतना छोटा नंबर आता है 0 करीब आता रहेगा उसी का यहाँ पे
In this case, it's asymptote. Yeah. If we take the limit, then yeah, this is actually the asymptote, the limit line. For all case, the x-axis will not be the asymptote. The limit will be, suppose some function fn is tends to a when n tends to infinity. So this line is basically asymptote.
Okay, ma'am.
So y equals to this. Okay.
Okay.
Yes, ma'am.
Here you, in
Ma'am,
this case, fn is tends to 0. So y equals to 0 is basically the asymptote here.
ma'am, can you give some example of divergent sequence?
Yeah, this is example for the divergence. Okay.
डाइवर्जेंस में नो लिमिट, हम इसको
See,
2 के पावर
when
x को भी हम डाइवर्जेंट
n
नहीं बोल
tends to
सकते हैं.
infinity, f of n equals to n again, right? So when n tends to infinity, f of n will be again tends to infinity, right?
Infinity,
Ma'am,
yes.
means we can take 2
But
to power n for this.
2 power n.
ये
This is
भी
also tends
डाइवर्जेंट
to
की कैटेगरी में
infinity
आता है, कन्वर्जेंट भी
when
बोल
n
सकते हैं.
tends to infinity. And infinity is not in real number. So this sequence is divergent, okay? This
Yes, ma'am,
is a
got it.
divergent sequence.
Ma'am,
Yes.
I have seen somewhere on the internet that the first sequence, it was basically they were summing n natural numbers, and it was sum 2 minus 1 over 12, something like that.
The
I mean,
first sequence.
yeah, it was
Yes.
summing from 1 to infinity. So
Yes.
intuition tells that it would, be divergent because it will tend
Yeah,
to.
this is divergent. Yeah, this is divergent. No problem. If we take this sequence 1 by n, so you can see if we take this fn equals to 1 by n, so this is our sequence, right? 1, 1 by 2, 1 by 3, and so on. This is our sequence. So you can see here when n tends to infinity, 1 by n tends to 0, right?
0. Yes, ma'am.
So this is a convergent sequence.
कन्वर्जेंट मैम सिंपल वर्ड में जैसे किसी नंबर के एकदम करीब जाता चला जा रहा है, जैसे 0 के एकदम करीब जाता है, उसे कन्वर्जेंट बोलते हैं, और
Yes.
जिसका कोई लिमिट नहीं है वो डाइवर्जेंट.
Yes. When we have this condition, basically, as n tends to infinity, this is our fixed condition, and a is basically variable, any real number. As n tends to the infinity, if n tends to any real number, then we will say the sequence is convergent. Otherwise, we will say that the sequence is divergent. Okay.
Yes, ma'am, got
Ma'am,
it.
give any example related, ma'am, practical example
These
related
are
to
the
that.
example, right? This is for the convergent sequence. Again, you can see something
Yes, ma'am.
like that f of n equals to minus n.
Hmm.
Then it will, when n tends to infinity, f of n will be tends to minus infinity, right?
Minus
This is
infinity,
again
yes.
a divergent sequence. Okay.
Yes, ma'am.
Suppose I'm now giving you 2 or 3 examples. You will say whether it will be convergent or not. This is one example. This is some,
1 by minus 1 into n.
yes, minus 1 to the power n.
Okay, ma'am, okay.
3. Suppose 1 by 1 plus some. Suppose you have 3 sequence here. So what is the first one? What is
Ma'am,
the first?
divergent. Divergent.
1 upon 1.
Because this is basically
It will be
minus
never 0.
1
Yes, ma'am.
plus 1.
लेकिन
Not
मैम ये भी तो 1 के
we-
करीब ही जा रहा है ना.
Ma'am, but it will never be 0. That's why it will be divergent, right?
we don't want 0 here, okay?
नो, 0
If
नहीं, किसी
there
के नंबर
is
बस
Close
करीब
any
to
जाते
real
हैं.
0.
number, if
Close.
they no.
Oh,
If it is close to 0, then the limit of the sequence is 0. But
Yes.
if it can be any real number, okay?
Yeah, is close
Because
to 1,
here
so
we
that
have
limit is
this,
1.
see, here this condition is valid for any real number, and in this case, the a is said to be limit of the sequence, okay? It not
ma'am.
necessarily 0. Okay.
मतलब लिमिट के सामने जो भी नंबर रहेगा समझ लो वही है, कोई 0 कंफर्म नहीं है कि 0 ही होगा बस.
So in this sequence, this we can see this is +1, -1, and so on. So basically, is it tending to some number, any number?
No.
हम
No,
अगर
sir.
n even लेंगे तो पॉजिटिव आएगा, अगर ऑड लेंगे तो माइनस में
No.
आएगा.
Yes. For n even it's +1, and for n odd is a -1. So is it tending to any real number? Is it
No,
isn't
ma'am.
not
No.
look it's a fluctuating function, right? +1,
Yes, ma'am.
-1, +1.
Divergent.
So it's basically a divergence. So when n tends to infinity, we don't know what is the number, whether it is +1 or it's -1, right?
Okay, ma'am. Got it.
So this is
जिसको जीरो
basically
पॉजिटिव का कंसेप्ट आता होगा वो समझ जाएगा तुरंत इसको.
yes. So this is basically a divergent sequence. Now what about this?
मैम ये कन्वर्जेंट.
Convergent.
Yeah.
कन्वर्जेंट.
And this is convergent to 0, right?
Yes.
This is
ना मैम 1 के
convergent to
पास
0.
कन्वर्जेंट टू
Why?
1 मैम, क्योंकि जितना वैल्यू माइनस में जितना वैल्यू बढ़ता है उतना छोटा होता चला जाता है. तो 1 से जितनी बड़ी वैल्यू को भाग देंगे उतना छोटा नंबर आएगा, और जितनी छोटी वैल्यू से भाग देंगे उतना बड़ा नंबर आता चला जाएगा, 1 के करीब जाता चला जाएगा.
Okay. How will be the graph when n equals to 1? This is -1, right? When equals to 1, this is -1.
But the line tends to it gets close to the x-axis, right? So it's convergent, right?
It will be something like that, right?
Yes, ma'am.
From the negative side. Basically, when n tends to infinity, -n will be tending to minus infinity, right? So you can see -1 by n is tends to again 0, right? Not
Yes,
1.
ma'am.
Okay, -1 by minus infinity is equal to 0.
Yes.
Okay.
Whether it is plus or minus, this is not our concern. 1 by plus infinity is also tending to 0, and 1 by minus infinity is also tending to 0. It's just matter of the side. Okay,
लेकिन मैम
1 by
एक ये भी
minus
कॉन्सेप्ट है
infinity.
ना मैम कि
Okay,
मैम
this is the
एक से
concept. See, listen to me. When 1 by minus infinity is tending to 0 from this way, from this path, okay? And 1 by plus infinity is tending to 0 from this path, from the positive side, and this will tending to 0 from the negative side, okay?
negative side. Oh yeah.
So basically,
Thanks, ma'am.
whether it is plus infinity or minus infinity, 1 by any infinity will be tending to 0. This matter what is the side. Minus infinity will be from the negative side, and plus infinity will be from the positive side, okay?
Positive side, yes.
Clear.
So yeah, what is what is your
Divergent, ma'am.
conclusion?
Divergent, maybe.
Convergent.
नहीं,
So you
convergent है
can
मैम.
try it. You can try it. We have
Convergent.
f of n equals
ये
to
लगभग 2 के करीब जाता
1
जाएगा.
plus 1 by
मैम स्क्वायर.
you are doing some mistake. You have to
ये तो
do
मैम
it step by step. See, you have to do it
मैम ये तो
step by
लेक्चर
step.
में भी
You
दिया
have
गया
this
है.
function. Yes.
मैम ये लेक्चर की शुरुआत में तो प्रैक्टिकली करके प्रोफेसर जी ने दिखाया है.
Okay. That's fine. Then you should tell me the actual answer. What will be the limit for this
मैम
function?
मैम कन्वर्जेंट है और मैम 2 के करीब जाता जाएगा. 2 के करीब एकदम, मतलब 2 नहीं पहुंच पाएगा लेकिन 2 के करीब जाता जाएगा.
You
Limits
are
to
saying
1.
it's convergent to 2, right?
Converges to 2
You are
or
saying
1.
this.
नहीं
Any
इतना बड़ा
answer
नंबर
from
है.
any?
छोटा चला
Converges to
जाएगा.
1.
1 मैम 1 मैम
मैम
क्योंकि
1
2
के
के
करीब
करीब
जाएगा
जाएगा.
ना मैम 1 के करीब जाएगा.
सॉरी, यस यस 1
Yes.
के करीब.
So you shouldn't be confused about it, okay? This is not right. This is wrong.
यस
You
मैम
shouldn't
रॉन्ग
be
मैम.
confused. You should do this step by step, okay? See, when n tends to infinity, we know n square will be tending to infinity, right?
Yes, ma'am.
So 1 by n square will be tending to 0.
Yes,
Then
ma'am.
1 plus 1 by n square will be tending to 1.
1 plus 0 is 1. Yes, yes.
Right? So you should do
Yes,
it
ma'am.
step by
Understood
step.
it, ma'am.
Yes. So this is how you have to calculate the limit for a sequence. What is a subsequence? Suppose you have a sequence Fn, that is F1, F2, and all. So if we are taking some NR, FNR. Fn1, Fn2, Fn3. Suppose we are denoting this, and this is a subset of this sequence, and this Fn1 is, suppose, F1, Fn2 is F3, Fn3 is F5. There's something like that. Okay. Then basically this is the subsequence for the sequence Fn. Okay. Is basically a subsequence, basically a subset or a sub collection of the main sequence. Okay.
Yes, ma'am. Got it.
You got my point?
Yes, ma'am.
Yes, ma'am. Yes,
Yeah.
ma'am.
It's basically a
Subset of the
subcollection
sequential.
or yes, subset of the range of the function
Yes, ma'am.
function f, which is our sequence, right?
Yes, ma'am.
Yeah. So it's basically a subsequence. Now you know what is a sequence, what is a convergent sequence, what is a divergent sequence, and what is subsequence. So any doubt related to this?
Ma'am, the subsequence will be in random orders or it will be in a order like if
It
1,
can
3,
be,
5.
yeah. No. You, if you were taking, suppose, this point and this, the third point and all, this is fine. Also,
Yes,
you can take the F1, F2, some F6, F8.
It can be
No
in random
problem. It
order.
can
We
be
can
anywhere.
we can
Yes,
pick anyone. Yes, ma'am.
yes, this can be anywhere.
Ma'am, so
Just a sub-collection of the range, okay? It's just
ma'am,
a
but
sub-collection.
ma'am, if we take randomly, then how we will have any idea of the main sequence if we will put it in any order?
No. We shouldn't change the order. Like, this should be in increasing order.
Oh, I see.
This should be an increasing order. Don't do like that F2, F1. I'm not saying this. This is not right. You can pick any entry from here, but it should be in increasing order, okay?
I see, ma'am. Ma'am, can I
Ma'am,
have
like
some
coordinate
example?
your side.
Can you repeat again? Like, I don't understand how this works.
Ma'am, just take an example. I think everyone will understand with that.
Okay. So in general, we basically check the subsequence in a proper pattern, okay? So suppose you have n. So for this, we can take three subsequence, like two subsequence like that, even and odd. These two can be subsequence for us, right?
Yes, ma'am. I see.
Because here is, suppose you have F1, F2 and all. Here we have F2, F4 and all. And here we have F1.
1, F3.
So this is an example of a subsequence. Again, you can take something like that. See, if again I'm taking the same sequence. So one sequence can be F1, F4, and this can be F2, F5. This can be F3, F6, F7, F8, F9. This can be in that way also. Then this sequence has three subsequence, right?
I see, ma'am. Yes, ma'am.
Not necessarily you have to take the even and odd basis.
Means sequence
It's
can
only
be a function,
subsequence.
but subsequence cannot be necessary to be a function, right, ma'am?
No. This is a function in
Ma'am,
this domain.
subsequence.
This is a function in this domain. For this, the domain is 1, 4, 7.
Ma'am, I'm
Ma'am, so
saying that,
the
ma'am.
function is same. Ma'am, so the function is same, but in subsequence, the domain can be different.
Yes. The domain is different, but this is function. Like we are basically restricting the domain. You can see here we are taking F1, here we are taking F2, F3. That means
Limited
what?
domain.
We are,
Yes, ma'am.
yes, we are just restricting the natural number, right?
Yes, ma'am. I understand.
This set is subset of the natural number, right? So
Yes,
basically,
ma'am.
if we take the restriction of A, suppose the set is A, F to this set A, then this is our, suppose this is our F star sequence. So this is basically our F star sequence. Okay.
Yes, ma'am.
Basically, this is our subsequence. So it's a sub collection of the range. So basically, we are restricting the domain and then we are finding a sequence.
Understood, ma'am.
Yeah. So any problem with the concept of sequence? Then if you don't have any problem, we will move to the concept of limit of a function. Otherwise, we will pick your problem doubts and we will try to solve it.
No, ma'am, no problem.
Yeah. So we can now move to the limit of a function. The limit of a function, it is basically a general case for a limit of a sequence. In the case of sequence, we see when n tends to infinity, fn tends to some real number, then we are saying that it is a limit for the sequence, right?
Yes, ma'am.
So if we have some arbitrary function from some arbitrary domain to the real number, here I am taking a real valued function. So this is basically a general case of this limit of a sequence. Like if n tends to any extends to any real number, it not necessarily infinity. This is not infinity. This is any real number. It can be again infinity and minus infinity. It include. So then the functional value of x will be tending to some number. If it tending to some number, then we will say that the function has limit. The function f has limit at x equals to a, and the limiting value is the limiting value is L. Okay.
Okay, ma'am.
Or in simply, we'll say limit exists for the function f at
X is equal to A.
Okay.
Yes, ma'am.
So you got the difference between limit of a sequence and limit of a function, right? So in the case, when we are talking about limit of a sequence, here n was tending to infinity. But in this case, this x should be, this x can be tending to any real number, or infinity or minus infinity. Okay.
Yes, ma'am.
So if we have that our functional value is tending to some real number L, when x tending to A, this set. So in this case, we will say the function has limit at x equals to A and the limiting value is L. Also, we can say the limit exists for the function at x equals to A. Okay.
Okay, ma'am.
And in particular case, in particular case, if L equals to f of A, then we will say the function f is continuous at the point A, at x equals to A. Fine. So we know what is limit. If in particular our limit is equals to the functional value of the function at that particular point, then we will say the function is continuous at that point. Okay.
Ma'am, when x tends to a, the function tends to
limit of function.
One by one, please. I can't hear you.
Ma'am, can you please repeat the limit of function?
Okay. So I'm just basically comparing the concept from limit of a sequence to limit of a function. So in that case, limit of a sequence, what did we see that if n tends to infinity, the functional value will be tending to some real number. In that case, what we are saying that the sequence is convergent and the real number, this real number A is limit, right?
Okay.
Limit for the sequence. Now here, when you are coming here for a general function, for a function, what we know that this domain is particularly our natural number, right?
Yes, ma'am.
For a sequence, the domain was particularly natural number. And for a function, the domain is something,
Real number.
something. What is a subset of real number. It can be the whole real number. It can be natural number. It can be integer. It can be rational number. It can be anything. Okay.
Yes, ma'am.
So basically, you can see it in this way. For a sequence, it was a function from the set of natural number to real number. So the domain was particularly natural number and the codomain was real number.
Real number.
And for any function, we have
Domain
the
is
domain A, which is basically a subset of R.
real number.
And the codomain is real number. So you can observe that this is a general case for the sequence, right? This A can be natural number also. This A can be natural number. This can be integer. This can be rational number, right?
Any type of number.
Yes. So this case, the sequence case, is a particular case of this functional case, right?
Yes, ma'am.
So when the case is basically same when we're talking about the limit. Okay.
So, ma'am, we can say that when we have a limit of a function where domain is a natural number, then it is a limit of sequence.
Yes. Yes. So when the domain is particularly natural number, then the limit of a function will be limit of a sequence. Yes. And this is as the function is basically a general case for a sequence. And alternatively, you can say a sequence is a particular case of a function, right? Real value injective function. Yes. So the limiting sense is also basically the same. For the sequence, we had n tending to particularly infinity. But for the functional limit, we have x tending to, or you can take n here also, x n tends to some real number or infinity or minus infinity. Okay.
Ma'am, can we have a general idea like what limit is really means what are the mathematical uses of this limit? And means ma'am, how it looks on real life solutions, so like real life mathematical problems.
Okay, we will discuss the examples also. First, I'm just trying to clarify you the definition. First, you try to digest the definition. Then
Okay,
I will again discuss the example also. So what I want to say that the limit of a function is basically a general case of the limit of a sequence. And did you get my point?
Yes, ma'am.
Yes. So it was a particular case we're taking n tending to infinity, and here we're taking extending to any real number or infinity or minus infinity. So basically, this is a general case. So here,
Yes, ma'am.
when in tending or extending to any real number or infinity or minus infinity, if we have that the functional value will be tending to L, then the L is said to be limit. And if particularly L equals to f of a, then
Yes,
this
ma'am.
function is said to be continuous at the point x equals to a. Up to this, the concept is clear to you, right?
Yes, ma'am.
Yes,
Okay.
ma'am.
So we can draw some conclusion that
Ma'am, does
for
this
me,
have, ma'am, does this have any graphical representation of limit?
yes. So suppose this is our function, this is our natural set, or this is our
Yes, ma'am.
a. Suppose this is our a. So you know the graph for exponential function, right?
Yes, ma'am.
Something
ma'am.
like that. So you can see when x was tending to minus infinity, the functional value was tending to zero, right?
Yes, ma'am.
So we can say at x equals to x as x tending to minus infinity, the limit of the function of
Is equal to 0.
f is 0. Okay.
Yes, ma'am.
And suppose we have here some. So if in this case, we can see when x was tending to infinity, function of x, it was again tending to infinity, right?
Yes, ma'am.
But this infinity doesn't belongs to real number, right?
Yes, ma'am.
And in this case, we will say limit doesn't exist.
Could you repeat that again?
So what was the definition? When extending to some real number or something, real number union infinity or minus infinity, fx will be tending to some L, which is a real number. In that case, we were saying f has limit L, right? But in this case, we can see extending to infinity, then that implies fx tending to infinity. But infinity is not a real number.
Yes, ma'am.
So basically, in this case, we cannot find this L. Here, such real L doesn't exist, right?
Yes, ma'am.
So basically, the limit is tending to infinity. It's not a real number. Okay.
So, ma'am, when we get
can be the limit in a sequence.
If it is a sequence, if it were a sequence, then we would call the sequence as a divergent sequence, right?
Yes, ma'am. Yes, ma'am.
Yes. And since we are just looking for a function, this is a function, a general case of a sequence. So tending, we're just talking that this function has no like real valued limit. This functional value will be again tending to infinity when x tends to infinity. Okay.
Ma'am, here we have seen like x tends to minus infinity, then the f is 0. So we can tell that it is continuous at 0. The function is continuous at 0 as such.
We're taking x tending to minus infinity, not 0.
Oh, yes, ma'am. Then we can tell x, it is continuous at minus infinity, right?
When, yes, when x tends to a, if x tending to a implies that f of x tending to f of a, then we will say the function is continuous at 0. Continuous at a. Okay. So here again we can check when x tends to 0, what will be the value of e to the power x? E to the power x will be tending to 1, right?
Yes, ma'am.
Here you
Yes.
can see when x tending to 0 from the positive side or from the negative side. When x tending to 0 from the positive side, let me use a different color. So here we are taking x tending to 0 from the positive side, okay? Then our functional value is tending to 0 from the positive side, right?
Yes, ma'am.
Yes, ma'am.
And when x tending to 0 from the negative side, the functional value again tending to 1, right?
Yes, ma'am.
Yes. So the limit when x tends to 0, then e to the power x equal tending to 1. So this is our limit, right?
Yes, ma'am.
Again, f of 0 is 1, right? E to the power 0 means 1, right? So basically our limit equals to f of 0. So in this case, we will say the function, exponential function is continuous
Continuous.
at yes,
X
this
is equal to 0.
0.
continuous at x equals to 0.
Hmm.
So you know the concept about left-hand side limit and right-hand side limit, right?
Yes, ma'am.
We know
Positive
it,
limit
ma'am,
or
but
negative limit.
We
Basically,
were taught it in 12th.
yes.
but if we can revise it, ma'am. No.
I
Yes,
will.
we can revise.
So here in this case, when x was tending to 0 from the positive side, this is basically a positive limit. Like if we are doing something like that, limit x tending to a plus fx, that means suppose we have a function. This is a function, suppose, and this is our a point, okay? This is x equals to a. So extending to a from the positive side, that means extending to a from the right side, okay?
Yes, ma'am.
Yes, ma'am.
See here, if tending to a from the right side, that means this is basically a extending to a plus, okay? Positive
Yes,
side
ma'am.
of a. And if x tends to a from this side, then we will say it extends to a from
A minus.
okay.
Yes, ma'am.
So this is clear to you, right?
Yes, ma'am.
And the functional value is basically again same. The functional value it's tending, if it is tending from the right side, then it is the limiting value will be this.
FA.
Yes. And if it is tending from the negative side, then the limiting value will be tending from the negative side. Okay.
Means LHS is equal to RHS, ma'am. Yeah.
Yes. And if limit extends to a positive and extends to a negative is same. Basically, if right hand limit and left hand limit are same, then we will say the limit exists.
And it is continuous, right?
If it is equals to f of a,
Oh, there is a third condition.
then it
Yes,
is
ma'am.
continuous.
Hmm.
Otherwise, limit exists. Okay.
Got it, ma'am.
So this is basically the concept for left hand limit and right hand limit. So suppose you have a function like that. You know the box function, right?
Oh, yes, ma'am.
Yes.
This is
Okay.
basically the greatest integer function, right?
Oh,
Okay.
yes, ma'am.
Floor function.
Yeah, ma'am. Yeah, ma'am.
Yeah. Floor function, box function,
Oh,
so many names are there. So greatest
GIF.
integer
cause of
value
name, video and gate.
less than x. You know this function. Suppose we are taking here fx equals to the box function. Then the graph will be something like that, right? This.
Stepwise.
Yes, this is a stepwise function.
Yes, right.
This type of, right? Sorry. Right?
Yes, ma'am.
So
Yes, ma'am.
this is our point 1. So what is the left hand limit and right hand limit? What is the right hand limit? First tell me. Limit x tends to 1 plus fx. What is the value of this?
It will be 0 and 1 plus. I think, ma'am,
Yes.
it will be some 1 or closer to 1. Means
If it is from the, if we
Right
are
hand side.
taking x from the 1 plus, that means we are taking the limit from this side, right?
0.
Right hand side. So the functional value is here, right?
Yeah, ma'am.
that will be
Yeah.
closer to 1 maybe.
This is 1, right?
Yes, ma'am.
Ma'am.
This is 1. This is 2. This is 3. Right? So this is 1.
Yes,
And
ma'am.
if we are taking limit x tends to 1 minus, that means from this side,
0, ma'am, then.
then the value is 0, right?
Yes, ma'am.
Yes, ma'am. Then the value is 0.
So here limit doesn't exist.
Yes. This is 0. And 1 not equals to 0. So the limit basically doesn't exist. Suppose we are taking mod x. So what about the limit and continuity? So here you can run a conclusion here. This limit doesn't exist and clearly this function is not continuous, right?
Yes, ma'am. It is discontinuous function.
Yes, this is a discontinuous function. So what is
Every integer.
It is a continuous function, maybe, ma'am.
Excuse me, ma'am.
Yes.
If we are getting the LHS and RHS both as infinity, then it will be continuous or not?
No. Continuous means continuous means at that point when you are taking limit x tends to a, this value should be
Real number.
f of a. This should be a real number.
Okay, ma'am.
If it is infinity, that doesn't belongs to the real number, right? So this is not possible for any a such that the functional value of this point is the real number, the infinity, right?
Yes,
Okay,
ma'am.
ma'am.
So there are functions which are for which the limit exists, but it is not continuous. But from the definition of continuity, it's clear that if it is continuous, then limit exists, right?
Got it, ma'am.
So continuity imply limit. This is clear.
Ma'am, if here, ma'am, if we take a value lesser than 1, like 0.5 or something, then the limit will exist or not in that GIF function?
In this function, what you are taking?
0.5 or like 2.5 or something like that.
0.5. Yes. In that case, this limit will exist.
Yes, ma'am. Thanks, ma'am.
Because from the positive side, if you are taking from the positive side, then also the functional value will be 0.
And
And
then
from
from
the
negative side.
also, the functional value is 0. And what about the continuity of this function at that point?
I think, ma'am, this is continuous function.
This is equals to 0. And this is equals to f of 0.5, right?
Yes,
So
ma'am.
it's clearly satisfying the condition for continuity. So this function is continuous at the point 0.5.
Yes, ma'am.
But it is not continuous at the point 1.
Means it is defined only for a particular point, not as a whole.
No, this is defined everywhere, but the function is not continuous at some point.
At integers.
This function is defined all over the real number.
No,
Okay.
ma'am, continuous. I was saying
But
continuous.
yes. So this is clearly this is not continuous in at 1, at 0, at 2, at 3. Like in integer points, the function is not continuous, right?
Yes, ma'am.
Yes, ma'am.
It will be continuous over R minus Z, right?
Yes, ma'am.
So what about the mod function?
It is continuous indeed.
Yes. So clearly we can draw the graph in one term, right? So this function is continuous. This is the
Yes,
first.
ma'am.
Yeah. So when x tends to 0 from the positive side, what is the behavior of the function? This will be tending to 0 from the
0
positive
only.
side. This will be the direction, right? Again,
Yes,
if
ma'am.
we are taking f extending to 0 and minus, this way, the functional value will be again tending to 0 in
0.
this way. In this way, right?
Yes, ma'am.
Yes. So both the value are same, hence limit exists and f of 0 equals to 0. So it's continuous at x equals to 0.
Ma'am, if in this function we take 1 or 2 and then find the limit, will be there any difference?
Suppose this is 1.
Yes,
Okay.
ma'am.
We are taking f extending to 1 plus from this side. So what is the value? This, right?
Yes, ma'am.
So this is again 1, right? And again, if we're taking extending to 1 minus, this is 1 minus, right? And
Yes,
the value
ma'am.
will be again tending to 1, right?
Oh, yes, ma'am.
For this case, it was something like that. Other, if extending to, suppose at 2 point we're checking. So when x was tending to 2 plus, that means from the positive side of 2, the value were tending to 2, right? But when we're taking extending to 2 minus, that means from the negative side of 2, then the
Then
value
it's
were
1.
1. This, right?
Ma'am, one more question, ma'am. When we talk about 2 plus and 2 minus or 1 minus or 1 plus, ma'am, how close we are talking about? Means how close it is to the real number 1? When it is when we will talk like 1 plus, then how close it is to 1?
As
It is
close as
almost
you can take. As close as you can take.
Oh, like ma'am,
Almost that point.
ma'am, in mod function, if we like take 1 plus, then in that point I am taking 1.1. So the mod result will also change, right?
Yes. 1.1 is a bigger number.
Big
Really a
number,
bigger
yes, ma'am.
number.
I
It
got
can
it then.
be
It must be
1.
smaller, like 1.00001.
Infinite
I got it,
times
ma'am.
0 than 1. Right?
ma'am,
It should be
Got it, ma'am.
represented by
closer.
h. Ma'am, the smallest the thing which is near to it, and the difference is, I think so. It is represented by h.
The difference is not basically defined because for real number system, we can't find the difference between 2 points, right? This is
Yes,
a
ma'am.
real line. For real number system, we can't find difference, like there is difference between 2 points, but there is no proper sequence. For natural number, we can see there is a sequence 1, then 2, then 3 and all, right? But for real number system, this is not the case. Can you say that what is the number just after 1 in real number system? Is it
No,
possible?
ma'am.
No, ma'am.
Yeah. But for the natural number system or for the integer, even
Integer.
for the rational case, we can conclude it.
But real number we cannot say.
Because real number system is uncountable. We cannot count the number.
Yes, ma'am.
You can say this is a number closer to, suppose 10, 0, then 1. This is a number closer to 1. Then I can add 2 more 0 here. Then I can say this is more closer. One can add 3 more 0, right? So the distance is basically the just immediate number is not basically defined here. But this
Got it,
exists.
ma'am.
Yeah. Okay, so I think your doubt got clear, right?
Yes, ma'am.
Yes,
Yeah.
ma'am.
So the right hand limit, you just learn the concept about the right hand limit and the left hand limit. So any doubt regarding the right hand limit and left hand limit?
No, ma'am.
No, ma'am.
Okay. Okay. So we got that for a function, what is the right hand limit, what is left hand limit, and also we know that when the both sided limit will be same, then we can say limit exists for the function, right?
Yes, ma'am.
And if the limit is equals to the functional value at the point, then we will say the function is continuous.
It's continuous at that point.
So here we can note a difference between limit. When we're talking about some limiting value extending to a, for limit, this a not necessarily belong to the domain.
Oh.
Not necessarily. Okay.
Yes, ma'am.
But for continuity, we want this condition, right? That means we want the function to be defined at that point, right?
Yes, ma'am. Then it should be in domain.
Domain necessarily. So this is the difference between two functions, right? Okay.
Yes, ma'am.
Like if we have this point, we can talk about the limit when extending to minus infinity, but we cannot talk about the continuity when extending to minus infinity.
Yes, ma'am. Because
minus infinity
it is
is
not in
not
domain.
in the set of real number. Yes,
Yes,
this is
ma'am.
not in domain. So basically,
We-
this is a major difference between limit and continuity.
We can take any point in limits, but for continuous, it must be in domain, right?
Yes, for continuity, it must be domain. Otherwise, the functional value at that point may not be defined, right? There is
Yes,
no
ma'am.
guarantee whether the functional value function is defined at the point if it is not from the domain. So
Yes,
this is
ma'am.
a difference between limit and continuity.
Got it, ma'am.
Okay. So now I think we can. I think these are all the concepts which you learned through your week 7. We can now just pick some random examples.
Yeah.
So if you are clear with the concept, then we will start doing examples. So are you clear with the concepts?
Ma'am,
Yes, ma'am.
the concepts you have taught just now, it's clear, but I don't know about the lectures because I haven't watched it yet. But if the examples is going to be like what you have just taught, yeah, it's okay then.
So you can later watch the lectures. Also, in the later class, you can ask if you are facing some doubt.
Okay, ma'am.
Now we will cover some example. This
Okay, ma'am.
example may not be in your recorded lectures. Okay, this may be something other than those examples. So these are some simple example.
Okay, ma'am.
So if we're taking our function equals to x minus 9 root over x minus 3. So first of all, at x equals to 9, the function is not, this is not defined, right?
X is equal to 9. It's going to be 0, no, ma'am?
It's going to be 0. Then it's 0.
No. This will be something 0 by 0, right?
Yeah, ma'am.
So this is not defined, right?
Ma'am, at x is equal to 9. Yes, ma'am. Yes, ma'am.
Yes, ma'am. It's not
At
defined.
x equals to 9, the function is not defined. Suppose I am taking 0 when x equals to 9. Suppose this is our function. So now the domain became whole real number, right?
Yeah, ma'am.
The function is from R to R, right?
Yes, ma'am.
Oh, yes,
Now,
ma'am.
yeah. Now let's check the limit and continuity. So, yeah, you can start doing. Then you can tell me what will be the answer. Limit extends to 3, 9. At the point 9, we are checking. Suppose at the point 9, We're checking the limit, okay? So what will be the limit?
Ma'am, if we are taking x tends to 9, then we will put 9 in place of x.
Ma'am, in question, why you have taken like x is equal to 9, then 0? Like, I don't understand it because it's going to be undefined, no?
It's x
Yes.
tends to 9.
But you have to do something with the function. Try to look at the function. What you can do with the function such that
Ma'am, if you
the
multiply,
function remains same and the value will be defined.
ma'am, if
Ma'am,
you
can
multiply numerator and denominator by root x minus
minus 3 into root x plus 3 and then just cut off the root x minus 3 from it?
Ma'am, we can factorize x minus 9.
What?
We can factorize x minus 9
It cannot be
root x
factorized.
plus
It's not
3
quadratic.
or root x minus 3.
Yes, that is
Oh yeah,
also
it
what
can be.
Yeah, that can be good.
this can be right as this is not suppose this can be
Root x plus 3 and root x minus 3.
root x minus. Here we have root x minus 3. So clearly x tending to 9 plus x is not exactly equals to 9. So this is not equals to 0, right? So we can
Oh yes, ma'am.
cancel out this two term. Then it will be limit x tending to 0, 9 plus this plus 3, right?
Yeah, ma'am.
Yes, ma'am.
So this will be, now there is no problem to just
Put
put
9.
the value. So it will be 6, right?
Yes, ma'am.
So what is the left-hand limit?
So another thing is we have to make the function limit at 9.
Yes, yes.
Negative.
If there is no disturbance, if there is no disturbance with the function at that point, then it's fine.
Oh yes, ma'am. Let's see.
But if there is any kind of disturbance, then you have to do something with the function such that the function remains same. You are not changing here, we are not changing the function, right? The
We just
function is
manipulate.
basically same. But we are doing something such that this became defined.
Yes,
So what
ma'am.
is the left-hand limit? What is the left-hand limit at the point 9?
It's also 6.
Okay. So in a similar manner, we can do. Okay. So left-hand limit is basically, you can see, is same to the right-hand limit, right? So basically here, limit exists and this is equals to 6, right?
Yeah, ma'am.
What about the continuity?
It is continuous, I think so, ma'am. At 6.
Is it
Maybe.
is it 6 equals to f of 9? Is it?
Oh
Yes,
no,
ma'am.
ma'am.
How do you define the function? This as 0, right? X
Yeah.
equals to 9. The
It's 0,
functional
it's not
value was
6.
0.
So it's not defined.
basically not same, right? 0 is not equals to same.
Ma'am,
So the function is
Not continuous.
ma'am, can I ask one question?
yes, yes.
Ma'am, in question you have taken x is equal to 9 and the value is 0. Ma'am, how it is possible there? I don't understand.
We're defining the function in that way. We're defining the function when x not equals to 0, then the function is this. When x equals to 0, then the value is 0. We're defining the function. We're just taking a random function here.
X is equal to 9.
At the point x equals to 9. For being function, we need to the function to be defined at every point of the domain, na?
It was
So,
just, ma'am, I was thinking that if we put x is equal to 9, then it's not going to come 0. So that's what was
That is,
confused about.
yes, that is why we need to define the function for x equals to, suppose this is this, the definition is up to that, just this line. Then at x equals to 9, the function is not defined, right? We will get some 0 by 0 form.
Yes, ma'am.
But we need the functional value at the point 9 also. So we
So
take some value. It's 0. Here it's 0. We can take 1, 2, anything, any real number.
So we
here,
have to find the limit at which it will be 0, right?
yes, the function you can take, this is a random function, okay?
Yes,
First
ma'am.
function comes, then we will conclude about the limit and continuity. So this is the function. Also, we can define the function as instead of 0, if I just take at the point 9, the functional value will be 6.
Then it will be continuous.
Then it will be continuous, okay? If we take any number other than 6, it may be 5, it may be 4, it may be anything.
Then limit will exist, but it will not be continuous.
Yes.
Got it, ma'am.
So that's the, I think the example 1 is here too. Now we will check another example. Just a simple limit extending to -2, 3t squared plus t by x minus 3. This is our function. Suppose our function is this. F of t equals to this. This is suppose start when t not equals to 3. This is t. And suppose 0 when t equals to 3. Suppose 0. It can be any number also, but I'm defining the function as f of t equals to 0 and x t equals to 3. Okay?
Okay, ma'am.
So now we're checking the limit at extending to -2. So what will be the limit? There is no disturbance in this, right?
Ma'am, we can directly put -2.
Yes. So there is no disturbance here. If we just put simply -2 here, there will not be any type of disturbance, right? So it will be simply plus by -2 -3. So it's
9, ma'am.
But ma'am, in the above case, like the question above, there was actually like limit extends to -9. Like if we put -9, root of -9 is like a complex
not
number.
-9. Not -9. It was 9 minus. That means we are tending to 9, but from the negative side.
Ma'am, it means less than 9,
From
but
the
not 9.
9, it's not a negative number, right? It's bigger than 8.
No, ma'am, I was talking about this question. You were discussing about like -2. So you were putting it -2.
It is okay to.
There is no root, right? So there
yes,
is no
it's minus.
problem to put -2 here.
Sorry, I read it as 2 minus, but it was -2.
So it's clear?
Yes, ma'am.
So see, there is no problem with this point. We can just directly put here that t equals to -2, then we can conclude that, right?
Yes, ma'am.
So whether the function is continuous or not?
I don't think
Not.
so.
Not,
Maybe
ma'am.
not, ma'am.
Why? Why it's not continuous?
It is not continuous.
Why?
Ma'am, we have to check at F3 maybe.
Yeah. What we are doing in this math? We have seen that there is no problem with the function with the value x equals to -2. Then what we did? We just put directly x equals to -2 instead of the function.
Yes, ma'am.
Yes, ma'am.
So isn't it the value of f of -2?
Yeah, ma'am.
We're doing the same basically, no?
Yeah, ma'am. X
Yes, ma'am.
minus 2 and the fx also minus
Basically, because
2. Fx.
we are directly putting, instead of t minus 2, we are directly putting minus 2, right?
Yes,
Yeah.
ma'am.
So basically here we are finding the functional value of the function f at t equals to minus 2.
Hmm.
So this function is continuous, right?
Yes, ma'am.
Yes, ma'am.
So from this two example, this is sure that continuous function will exist, imply that limit exists, but not conversely, right? There are functions
Yes, ma'am.
for those, like limit exists, but it may not be continuous, right?
Yes, ma'am. Ma'am, you took that thing in right, t is equal to 3, and it was not even used.
Why it's not even used? We need to put the function, right? I'm taking example of a function. This function is this function at point t equals to 3. Is it defined?
No, it is not.
So we need to define the function for t equals to 3, right?
Yes, ma'am.
That is why we define the function at t equals to 3. Okay.
Yes, ma'am.
Now here we check the limiting property of the function at the point x equals to minus 2. You can also check it at the point x equals to 3.
Oh, so it's two different questions. Now, I thought both questions are
Yes.
same.
No, this is actually, see, we have a function here. We can talk about the limit of the, or about the
At
continuity
other
at
point.
any point.
Yes, ma'am,
At
I got
any
it, ma'am.
point, right?
I thought it was related to it. That's why I was
No.
confused.
We can talk about the limit and continuity at the point 3 also. But here we were talking about the limit and continuity at the point minus 2.
So, ma'am, directly we take LHD and RHD only when the function is not defined at that point, right? Or if it is defined, then we then directly put it and
Then
get at the
generally, if
value.
it is defined at both the at that point, then generally both the side are same.
Oh, yes, ma'am.
You can check it, no problem. You can check it, but generally it's same. But it
No, ma'am,
may not be. Like it is always good to check from both the sides. Like it depends, because see, f of x equals to mod x. This is defined at x equals to 0, right? No problem. But
Yes,
if
ma'am.
the left hand side and the right hand side limit both will be 0, right? So plus or 0 minus f of
Both
x
will be
will be
0.
0. Similarly, minus 1, minus 2, you can check whether if the function is defined at the point, generally they are same. So you can just check it. It's up to you. You can check it for safety.
So that's what I was asking, ma'am. It's okay if we check or not check. The answer will be same, right?
You can just look at the function. Is there any difference? Because if we have something root over here, root over x, okay, then 0 tending to positive side is defined, but x
But
tends to
negative side is
0
not defined.
minus is not defined. But in this case, your domain should be 0, right?
Yes, ma'am.
So here, it is enough to check for this case. This case is not necessary then. Even this is not needed. Because you need
It's
to
not
check
in
the
domain.
Yes. 0 is not
Got
in
it, ma'am.
domain, and negative side of real number is not in domain. So we don't need to check the function in that outside the domain.
Got it, ma'am.
So yeah, this was the formula. Limit x tends to 0, sin x by x. This is 1.
Yes, ma'am.
This formula you have, right?
Yes, ma'am.
Yes, ma'am.
And one more formula I want to tell you. I think you already know it. Pi by 2 tan x by x is 1.
1.
So based on this, suppose we are taking one function f of x equals to tan 3x, this is 3 by sin 2x at x.
Hmm.
And at x equals to 0, it will be something that the function will be basically defined all over the real number. So we are not, so what will be the value? Limit x tends to, okay, suppose pi by 2. Let us take pi by 2 f of x.
Tends to pi by 2. Ma'am, we have to do some partials when divided with the same.
Yes. This is tan 3x by sin 2x, right?
Yes,
So
ma'am.
we can do this. This is allowed here. Tan 3x by
3x.
pi by 2
Hmm.
sin 2x, right? This is allowed.
Yes, ma'am.
Now we can do x by x. Okay?
To bring it in a standard format now.
Yes.
Oh, it is gone.
Okay. What happened? I don't just got cancelled. So okay,
That
we
was
can
yes, ma'am.
again rewrite the question.
By sin 2x.
So limit x tends to
Pi by 2.
pi by 2 tan 3x by
Limit x tends to pi by 2. Sin 2x.
now we can balance x by x 2
2x by
over 2
3x.
3 over 3, right?
Yes, ma'am.
Then we can rewrite the function of our convenience, right? Limit x tends to pi by 2 tan 3x
By 3x.
right?
Yes, ma'am.
Okay. But here you can see one thing. When x tends to pi by 2, what is 3x tending to? 3 pi by 2, right?
Yes, ma'am.
But at that point, we don't have any problem here, right? So, 1 minute. I think it was 0 actually. It was not pi by 2. Oh,
Yes,
sorry.
ma'am.
Yes, ma'am. Because sign will not be defined at that point, maybe.
Sorry. Yeah. I did that mistake. If you know I'm doing something wrong, you should stop me, okay?
I thought you are dealing with another type of question. That's why I didn't say anything.
Yes. Yeah. Because for this we need some 0 by 0 form. At infinity, this was not. Okay. So
Yes,
this is
ma'am.
our condition. Now we're taking this as 0, suppose.
Ma'am, can you tell me why did you take 2x by 3x and into 3 by 2?
Yeah. We need to go to the standard form, right?
Yes, ma'am.
We know the value of limit x tending to 0 tan x by x equals to 1, right?
That's why.
We know the value of this type of thing. So we don't know otherwise what will be the value. So we can do it in that way. Otherwise, see, when we are taking some extending to 0, with this function, it will be in 0 by 0 form, right?
Yes, ma'am.
Not defined, right?
Yes, ma'am.
So we have to do something, again, we have to do something with the function such that it will be something defined, right? So
Yes,
just
ma'am.
Yes,
for
ma'am.
this, we are doing this. Now we can simplify this. 2x by 2 is 3 by 2. Right?
Yes, ma'am.
So now we can change the limit. Here we have x, here we have 3x. But we can change the limit, right? When x tends to 0, we know 3x is tending to 0, right?
Yes, ma'am.
Again, 2x is also tending to 0.
Tending to 0.
So we can rewrite this as limit y tends to 0, tan y by y, limit y tends to 0,
Sin y by
sin
y.
y by y into 3 by 2. So this value is 1, this value
And
is
this
also
answer will be
1
3
by
by
1.
2.
Yes, answer is 3 by 2. So is this clear to you, all of you?
Yes, ma'am.
Yes, ma'am.
Yes,
ma'am.
yes, ma'am.
Okay. So probably I will take one more example. This is last example from my side. Then if you have anything, any doubt or anything, then you can ask. Okay.
Okay, ma'am.
Okay, it's just a simple question. Suppose here at the point x equals to 0, we are just excluding the point 0 from our domain. Okay. So is it possible to talk about the continuity at x equals to 0?
If it was given, what was the value of?
No, suppose there is nothing given at the point 0, and our domain is here R star. R star means R minus 0. So is it possible to talk about the continuity?
No, no.
Ma'am,
ma'am, because
Because
what we know that for the continuity, the point should be necessarily in the domain, right?
yes,
Yes,
ma'am.
ma'am.
yes,
So we cannot talk about the continuity here. So this is the
Yes, ma'am.
last example from my side, extending to 0, root over x squared plus 9 minus 3 by x squared. If your task is to find whether limit exists for this function. If it exists, then what will be the limit? You have to find.
Okay, ma'am.
I'm giving you 2 to 3 minutes to solve it. You can solve it, then you can assist me.
Okay, ma'am.
Anyone?
Ma'am, it's just hard to manipulate this one because it will be undefined whatever we do.
Ma'am, we can set differentiate कर सकते हैं
If
इसे.
it is not defined, what we can do, we can adjust this function, right?
We can differentiate it.
So you can simply, you can differentiate it, but we are not covering the undefined form here. Okay, we are not covering the L'Hopital rule here. So what you can do, accept these things, accept this thing.
That's what I
If
am
we have
trying to figure
something
out.
under root, what can we do? We can take the conjugate over, right?
Yes, ma'am.
Yes,
So
ma'am.
let us try to do something in that way, and then let's see what happens. So we are just taking the conjugate here. Okay. Then what will it become? What will be the
A square minus B square.
so it
We
will
can
be
use
x
that
square
formula.
plus 9 minus 9, right?
9
Yes,
divided
ma'am.
by
It is x square
x
by
X square root x square
x
plus
square
9
plus
plus 3.
9 plus 3.
right?
Yes,
So
ma'am.
9 will be cancelled out and
X square can be cancelled. Yes, ma'am.
It's
then it
E
will
1
be
by
1 by 6, right?
6. Yes, ma'am.
Oh, yes,
So what
ma'am.
should you look for? Your primary concern is, first of all, you know what is the point of our problem, this x square, right?
Yes,
So
ma'am.
this should be your primary concern, how to remove this point. How to remove our problem, right? So first
I
you
did.
try to check what we can do to remove our problem. Then we can see there is x square plus 9 under root and 3 is outside. So it is possible if I do something square with the 3, then 9 can be cancelled out. If I take the conjugate simply, then 9
Yes,
will be
ma'am.
cancelled out. Then we can cancel the x square, right?
Yes, ma'am.
So when you are able to find your problem, the difficulty point, then your primary concern should be how to remove the problem.
I see. Ma'am, if at some case it will never be defined, then what we can do? Like it, whatever we do, it will be remain
If
undefined.
it is the case, then nothing is happening. Nothing is happening. Then you have the final one, L'Hopital rule
Oh.
for undefined case. But here I think they haven't even cover the L'Hopital rule or undefined
Yes,
form
ma'am.
in this week 7. That's why I'm right now I'm avoiding this. But but later we will cover. Definitely we will cover this form.
Okay, ma'am.
Yes. Right now you're just primary concern. You will be given that only that type of problem. You can balance something or you can manage something to remove your problem point. Okay.
Yes, ma'am.
Yes. So this is how you can what I suggest in with your
Adjust the
activity
function.
question. Yes.
Oh.
Adjust the function and try to solve many question over the limit. Not only your activity question and problem set, try to solve many other questions. You can find something from the internet, also from some book. Your 12th standard also there were limiting questions, right?
Yes,
So you
ma'am.
can check this and you can practice these things.
Okay, ma'am.
You will be more comfortable with this concept. So yeah, if you have any doubt, you can ask now. Otherwise, we can end up this session.
Ma'am, can you tell other than conjugate or rationalization, what we can do to adjust the function, like other things? Because this thing didn't come to my mind when I was solving it, conjugate
It
one.
depends on the function actually. It's actually depend on the function. If there is something to do, you can do something.
We can do factorization.
Yes, you can do the factorization, whatever
Rationalization.
you can do for to remove the problem point. Then it's fine. If there is nothing to do, then it is in the indefinite form, and then you have to apply the L'Hopital rule. You have to derivative it first, derive the derivative, then you have to take the limit. Okay.
Okay, ma'am.
Okay, so if you have any doubt, you can ask. Otherwise, you may give. We can then end up the session. So someone has asked some doubt with activity question. So the activity question and problem set will be discussed in the next session. So if you have anything regarding the concept, you can ask. Otherwise, you have doubt with the activity question or practice problem, then you can ask to the next session. It will be covered during the next session.
Ma'am, next session is on Wednesday.
I think Monday, you don't have any session on Monday? You should have, I
Let
think.
me see, ma'am.
Yeah, you can check it on your calendar. Maybe it on Monday, but Tuesday you have one class for Maths 1.
We have Tuesday at
Maybe I will be taking that class. Maybe I will
Yes,
be
ma'am.
taking
Solve with
that.
a section.
Yes,
Okay,
yes.
ma'am.
Before the solve with the session, we will have some open session and all.
Okay, ma'am. Thank
There
you.
is maybe.
Huh. There will be some open session over the activity, question and problem practice and all.
Okay, ma'am.
You will be taking that session, right, ma'am?
Maybe I will take. Maybe.
Oh,
Maximum
okay.
possibilities is to take.
I
Whoever
think,
is taking
ma'am,
it, it's not the matter. You can ask anybody about it.
I think no one have any doubts. Maybe it's
I
a
have
If you
question,
don't
but
have
not
any doubt.
I have question not related to the topic, but I want to know something because some of you
Yes.
have the suffix in your name after your names as POD. What is that?
Okay, this is some like point of contact. So there is some point of contact of each team. So there are so for them there is something after the name POD.
Oh, okay. Because I thought like it's something to do with the
No,
program
no,
or
this is
extra.
not. Yeah, this is not an to be concerned.
Okay. Thank you. Thank you.
So
Thank
yeah,
you,
you
ma'am.
Thank you,
can
ma'am.
do this. Yeah, yeah.
Thank you, ma'am. Good night, ma'am.
Yes. Good night.
Thank you for clearing our doubts, ma'am.
Okay, ma'am.